Hi, and welcome back to Codeweaver Writes Code. I'm going to continue where I left off yesterday, and that is with this. Let's go straight on into the other screen and hope everything shows up. There, so there's our problem space. I'm not going to read through this all again, because I did on the last part of this same tiny little series. But the basic idea is that when I was implementing a simple puzzle solution just for programming giggles, in Haskell for the advent of Code 2020 list of puzzles. The very first one was a very simple mechanism whereby we had to choose two numbers from a list, like find all pairs of numbers from a list that added up to a specific third number. In this case, 2020, because Advent 2020, right? But let's say arbitrarily for some n. Now, in the solution to that, it turned out that the part that did the searching, like the naive solution, try every possible pair of numbers, see if it adds up if to the target number. If it does, add the pair to a list. And then the puzzle had you then go and multiply those two values together to produce something for checking the final result. But I don't care about that bit because I'm only really interested in the search part. The mechanism that I chose, though, was to basically search forward and backward through the list and sort of oscillate around the target value using sort the list first because it's not arbitrarily sorted, then go from the front and the back and zero in on on target pairs of values by oscillating which list I advanced on one by one, whether or not it would take me above or below the target value. And if I happen to hit the target value during this process, then I would output the pair. And that reduces it from quadratic to linear time, and Bob's your uncle, except for the sorting part. So I guess that takes n log n. But the actual searching part of it, once the list is sorted, goes to linear time in a search. But I noticed that process of walking down the two lists sort of at different rates was something very similar to what I've done in my favorite sort of implementation of merge sort in Haskell, because it's really pretty to demonstrate there. I was, again, in that case, walking down two lists at different rates and doing something with pairs of values therein. And I decided, well, okay, let's see if I can make this a higher order function, because I love myself a higher order function. Give me a map and a fold and I can move the world. Maybe not. I haven't been doing that sort of functional style of coding for nearly as long as I've done the imperative style of coding in my lifetime, but I love the power of higher order functions. And so I decided, well, that kind of zip, if you will, that doesn't just go lockstep along two lists, bore a lot of resemblance. Could I make them the same thing without it just becoming an unwieldy, unholy mess? And so I did it in Haskell, which I will quickly show because it's not actually the target of this stream. But let me just flip over to that. So here's my targeted, I called it merge zip because it's kind of it came out of merge, sort of the merge action in merge sort. But basically, this takes an arbitrary function and applies it on pairs of values, but it also gets hints from the passed-in functions as to how to advance the two lists that I'm looking at. And because of my implementation here in Haskell, I can mimic the standard zip and zip width by basically just advancing both lists lockstep. And I can also do dot products, I can do the merge part of merge sort, and I can do that sums to n operation from that part of the Advent 2020 puzzle, and a bunch of tests, which we'll see. I'm not going to focus on this code. Pause if you want to take a look at this. Fill your boots. But this is the thing that I wrote, and I love me a Haskell. I think it's a great language for demonstrating good forays into interesting types and higher order abstractions. Yeah. So, having done that, though, it's like, well, that's great, but can I do it in some of the other languages I program in? Because I love taking stuff like this and applying it to languages that I maybe use more frequently, especially if they're not necessarily the standard way of solving these kinds of problems in those languages. So, next thing that I did, ignoring the colorful sirens outside, because I can't block those out, so I shut the windows, I'll bake in here. So having done that, let me see if I can do this in OBS without causing mass chaos. Let's turn off Programmer's Notepad, and there's my Visual Studio. So Visual Studio on this one shows the C++ version of this, because why not, right? Now, the problem with doing this in C++ is that, except for C++ 20 ranges, which, yes, I know C++ites, is definitely going to start becoming a thing, but I didn't do this in ranges. I did this in sort of standard iterator syntax, but the two problems with that is the iterators require start and end iterator instead of like one thing containing its own ability to stop at the end of an iteration. And that made doing it in the style just a little bit extra tricky because I had to pass around extra iterators. But also it's not lazy. C++ is strict, and I didn't want to try to pass in only iterators because of that pairing thing. I didn't want to reinvent ranges just to solve this puzzle. So this is strictly on vectors in this case, and I made a version of this that you won't see right away, if ever, that handles vectors and lists and multiple types of containers. Totally overkill, but this is what I came up with. It's actually pretty robust. It has to handle the tails a little bit differently when one of the lists runs out. A little bit differently than the Haskell version, but it works well, and I can do standard zip out of it. I got some helper functions that aren't terribly relevant. Some other Haskell-esque operations to just demonstrate the point, and none of this is very interesting. But there's the same list of tests, and it operates exactly the same. Very specifically, it solves the sum to n problems and the merge problems from before. Trying to make this recap as short as possible so I can get on to actually doing the work. So that's great. So C++ works okay. Would prefer to have done it in ranges. Didn't want to reinvent them. Yeah. So I compiled this under C++ 17, I believe, just under Visual Studio. Nothing spectacular there. Could have done it in GCC. But let's quickly also pop over to the solution for the C# version of this, which I believe is there. So the C# version, so C# has link, and link is sort of is basically a lazy list or a lazy iterator evaluation mechanism for collections, which operates a lot like iterators in, say, Rust or Python or whatever. And of course, I would argue that C++'s ranges are very much based on or adjacent to this in any case. And aside from some classes to support some abstract math stuff, let's get all the way down to here it is. And this is exactly the same code, except this one behaves a little bit more like the Haskell version in that it's lazy, a lazy iterator. You can like take all or part of the produced list. It takes in and emits enumerables, which are basically the iterators. Yeah, and it basically does what it says on the tin. Same thing, it can implement standard zip and zip with by just advancing both lists simultaneously, and then it can solve the sums to n and the merge part of merge sort just fine. And all the other tests are exactly the same. I like Link. I think it's great. I hope C++ ranges does this kind of thing justice, and I may revisit it at some point, but not really the point. I'm not going to go into any of these languages right now because the reason I started this series is because I want to learn Rust. It looks like an interesting language. It looks like it's threaded an interesting needle between Haskell and C++. It's sort of got some really strong typing, which I think borrows a lot from Haskell's type system, or at least is definitely adjacent to it. It borrows C++'s concept of zero-cost abstractions. It could conceivably be considered a systems language, which kind of appeals to me in a lot of ways, but it doesn't eschew from the generics. I love me generics. The interesting idea of separating out data structures from the dictionaries of methods that can operate on them. That I see in Haskell as well because of their type classes and the way that's handled, and I really like that. Yeah, lots to like. And, of course, it being fairly unique as a language to have its borrow checker for doing its memory management, which which makes it so that you don't have the news and deletes problem, the manual memory management, construction, deconstruction problems that C++ occasionally has. I've gotten very used to it, so it doesn't bother me, but I understand why it's a thing you might want to address in part of the language. But it doesn't rely on garbage collection like Haskell. Much as Haskell's garbage collection is like world class, it's really cool, love it. The idea of doing sort of being able to analyze whether things are in use or not in use at compile time using the borrow checker is novel, and I want to learn more about it. So there's all the motivations. Let's get right on to the rest, shall we? Because this is not what I want to be showing you, so we're going to kill that window. Now, we started this, geez, am I going to go through that preamble every time I start up this series? I better make this a short series, so I don't have to keep doing that. Here is my version of the code that I've been monkeying with. Nope, that is still the Haskell version. Doink. And that's the motivation file. Let's get rid of that. So I've been getting, oh, hello, Silent Z. Yo, you streaming again? Yes, thank you. Hey, great for showing up. I'm a little bit later today, but hey, like I said, I do this whenever I have spare time, and oh yeah, got me some Coke Zero and got myself some water, so I'm going to stay myself nice and hydrated and caffeinated. So I'm going to stick with the code that I've been starting to write here with my, let's see, what did I have here? This is, I got to recognize where I was in my code. Wow, is this where I actually left things off? I thought I had converted. No, this is where I let things off. I used the deconstruction mechanism here. I used the, for the iterator that I was building. Okay, yeah, so this is where I was leaving off. My next objective is to turn this into a zip with, because I'm going to need the, I'm going to need to be able to apply a closure, loosely a lambda as dictated by a calling function in order to implement zip with, and then I'll re-implement this function zip to just pass it a tuple creation mechanism. I'm going to stumble through this. So if you're looking for a Rust expert, find another streamer. I'm sure there are lots. I'm glad to have everyone here who happens to be listening. But I'm going to be stumbling through this because I'm going to bring in a lot of really, really bad guesswork from other languages, and I'm going to be reading up in some documentation on the fly to try to capture how I'm going to learn this. This is sort of trial by fire, if you will. But I did come up with a workable zip mechanism. Ish. It does require, I do not have a mechanism here yet whereby I'm calling the zip function with self, but I'm going to solve that problem. I think, should I do that now? That is going to require, require converting this to a function that, that is a member of the myzip structure. So I am not going to get quite as fancy as Silent Z's right away, because I want to try to recreate what he managed to do, or she, I didn't actually ask. They managed to do on the fly while I was stumbling about. So, so, first things first, let's see if I could actually do that conversion to make it so that I can use the syntax. What am I after here? Let's comment one of these out. We're going to say that eventually we want to be able to do this. We want to be able to do this dot myzip and just pass in the second one as a parameter and then issue collect. Which means that this standalone function isn't going to do this. I have to make it an actual, effectively a member of the myzip structure, but of course that's sort of a, C++ism or C#ism. What I'm really doing is, well, it's as good a way to state it as any, I suppose, but let's see here. So we don't need... think we can get away with that. Quick reference to, do I have, oh yeah, so by the way, you can see the advent of code description up in the corner. I'm getting rid of that too and turning on, where is it? The docs. So there you go. So you can see what I'm poking my nose into here. So quickly looking this up. Rust implement method for struct. So methods, yes. And so basically, impl point. That's what I'm going to do here. So this is impl myzip. Oops, don't want to do that. I'm going to try to minimize that now that I got my Windows set up. Impl myzip, and I want basically a function. See if I can do this now. Yes, I know. He or him. Hey, thanks. Perfect. No problem. Silent Z. I will try to remember that. Yes, I realize I'm going to be stumbling into stuff you already showed me, but I'm trying not to look at your code to see if I can work through this in my head, and I will refer to your code if I get stuck. Because I know that you kind of did this with a very clever little mechanism for being able to apply this to all iterators. But let me start here first to see what stumbling blocks I run into. So basically, I want my zip to be I wish I hadn't actually erased the old. Hang on a second. Oh, I did leave it alone. All right, so this is my original function. It just returns a myzip. So I want to be able to I'm going to have to be able to take in self as I think I'm probably going to have to take in self as a mutable reference. Because let me think about this for a minute. I'm going to have to walk through. I'm going to have to modify my own elements in order to be able to make this work. So, is that actually the case? Perhaps. Okay. Let's find out. So then we're also going to take, and actually, hang on a second. I'm not sure I'm going to need A because that's going to be part of self, isn't it? So let's find out. This is going to have to be mutable as well. I can't, I am going to be taking it as, am I going to be consuming this? I'm going to be taking and consuming. I'm going to say for the moment I'm going to take it and consume it. So that means that I'm not doing a borrow, but I do require it to be mutable. And actually, for the moment, I'm actually going to say that self requires being consumed as well. I'm sure that's going to have different consequences as I figure out where I accidentally consume it forever when I want to be able to reuse it. But I don't think I want that ever to happen, because if this is an iterator, the problem is if I mutate the internal values, I don't really, I can't really have someone else take that and continue from where I left off on that particular iterator. I would just construct a new iterator from it. That's interesting. Here's a question. Are iterators clonable in Rust? Or copyable, for that matter. In C++, for example, they are. They're generally considered just a pointer into memory, for example, of a particular type, or they are a start plus an offset index. In either case, well, I mean, there are a couple other representations you might find, but in either case, they're trivially clonable. In C#, without some jiggery pokery, iterators and enumerables are not clonable. The iterators, part of it anyway. Can't remember if enumerable from what you generate enumerators are clonable, but I have run into that complication before. Depends on the iterator. Okay, that's actually a good point. I presume if I wanted to restrict it to iterators that are clonable, I would constrain the input types on the iterator to see if they implement the trait clone. I do have to say it's going to take me a long time to get used to the sheer crazy number of traits that Rust seems to have, but I actually like that because that means I can test properties about the types at compile time, which makes me very, very happy. I don't like deferring that stuff to runtime. It drives me nuts. When it's, I mean, sometimes it's necessary, but when it's not necessary, being forced to do it at runtime drives me nuts. So sure, let's see if I can make this work. So effectively, yeah, let's see if we can just come on, behave. I am going to actually call this my zip 2-parameter or top level function or whatever you want to call it. Just want it out of the way so that doesn't interfere with the naming, because Rust doesn't allow overloading, which, coming from a C++ background, you'd think would annoy me, but I got used to it in Haskell. Overloading has some advantages and some really complicated library wizardry, but it makes reasoning about your programs sometimes a little bit difficult. Hit me. Of course, lots of errors because I don't know what I'm doing. Hi, Rust Noob. So expected type found keyword. That's because I put that in the wrong place, didn't I? That is just like on the self case. A property must mute. A property of the binding of the variable is not a property of the type. That's something that's going to take me a little while to get used to too. Is that mute is not a property technically of the type. At least from what I've understood from reading lots of Stack Overflow lately, among other things. And I kind of appreciate that, the idea of the way that you bind variables being different from the description of the type that they are. I actually found it's funny, I found a neat little article on Stack Overflow or one of those Reddit or somewhere in Reddit, talking. It had a line of Rust code that had the MUT keyword, the mute keyword, in 3 different spots in one line, and they all meant slightly different things. I can appreciate that because there's lots of stuff like that, like auto and C++. You just got to get used to, but I'm not there yet. So it's going to be, I'm sure, nigh unto painful for all the rustaceans that might pop by this thread, or this video. Cannot find value ix, and this go, why? Because I didn't call it ix, I called it b, so, and actually this is no longer ix, this is actually, okay. Now I've got to think this through a little bit. My zip needs to implement iterator, which it does. So for all intents and purposes, it's considered an iterator. So that means that self can actually go in here. Did I actually restrict these to being iterators in the struct? I did not. That's interesting. Find out if that bites me in the behind. Where is it? 49 says my zip expanded identifier found keyword self. Okay. If you are trying to do that extension method trick, that will need a custom trait. Yes, I remember that you implemented a trait to do this. And I guess my question is then, why is a trait necessary here? Because I'm implementing... Because my zip itself isn't a trait. Oh, you are implementing for myzip, so self in that case will be myzip. Sure. But I'm returning, I would have thought, a... hang on a second. Let me think about this. This should actually have a return type, which is myzip AB. Yes, this is actually what I'm returning. Except, no, that's not true, is it? I want to be able to return... Well, okay, am I returning a myzip, or am I returning an iterator as a... I guess it's a trait object here. I'm going to have to think this through. Because if I'm if I were to be implementing, for example, if I had an ordinary struct like a rectangle, I would simply be implementing ordinary functions, including possibly something that would return, that would act as a construction. For all intents and purposes, I would have thought. Oh, hang on a second. I am being very, very silly, aren't I? Because what's on the left-hand side of... hang on a second. For the sake of the syntax that I'm using down here, the iterator that I'm getting isn't actually my own type. I'm not actually implementing a myzip. What you're doing is implementing methods on myzip. Problem is you don't have a myzip yet. I was just getting there. That's great. I'm glad it's filtering through my head kind of sort of fast enough. Thinking about this through, looking at the actual syntax that I want to implement, what's on the left-hand side here, which actually is the self, like at the call site, this is not a myzip. I don't have, as you point out, I don't have one yet. I'll have one on the other side of myzip, like after I produce this, which then goes into the collect method, and the collect method will expect abstractly some kind of iterator, and if I implement iterator correctly, it should just work. So I wasn't thinking this through. The selected bit that I have right now is what will eventually be the myzip. But the left-hand side of this, or the self side of this, the implicit first, well, it's not implicit in Rust, but that first parameter that becomes self is some other kind of iterator. Now, in principle, what that would mean is effectively I would need something like, where effectively self is an iterator. But I can't do this. And in fact, basically speaking, what I'm saying is I'm not implementing for this. I'm actually implementing for iterator. Right. Like I want to basically add more functionality to all iterators, which, by the way, super cool. Like that comes at the cost of the fact that you could have a function that is legally allowed to be called for a type, completely separated by yards of code from the actual type. But it's a little bit like, for example, Link's extension methods, which, by the way, is exactly how I implemented the C# version of this. I created an extension method, basically allowing myself to add to the enumerable class, I guess, this idea of doing this merge zip, or zip merge, whatever I called it. Okay, merge zip with. Okay, so yeah, okay. None of this syntax is going to work, and I understand why, but I'm going to leave it on screen for the moment just to wrap my head around the fact that what I'm really doing is effectively implementing new stuff for iterator, but I can't actually do that. Right. Okay. Right. Haha. Create new trait. Yes, I realize this is painful for everybody who's probably watching this, that I'm looking stuff up on the fly, but it is awesome that Silent Z is acting sort of as a de facto coach because he happens to be here, but I don't want to rely exclusively on that. I need to be able to look this stuff up myself. Sure. So creating a trait doesn't look too big a deal, and because of the nice uniformity for the most part of Rust syntax, creating a templated version of this is not necessarily all that bad either. So I'm going to say something like trait I'm going to try not to bring into my memory naming conventions that Silence used, because I want to fumble about this myself. I'll call this my zippable. I think he called it with my zip or something. Whatever. I'm going to call it this just because I can. So I don't bring in any code into my head that I don't intend. And so basically for traits, I need to describe, oh my god, looking at this example, of course, they've got static keywords I don't expect and the lifetime tick marks that I remember using for my binary tree thing at some point way in the past. But that's not really relevant here. I'm going to say I need a function which basically does this kind of thing because I want to introduce this trait effectively into the iterator class. And I know that there was, okay, so right, so let me see, now I can't help but see in my head Silent Z's code. I remember he used the into iterator pattern. I'm going to try to avoid that until I realize why I need to do that. I think it's because the contains method ultimately down the road is if it sees something that is not an iterator, it'll use the into iterator pattern in order to turn it into one if it's supported by that trait. So you can't really implement methods on types that aren't yours. This is what happens. All right. I will get an education. So implement a iterator, a info string. Okay, let's try to do this build and find out what happens. Thank you for the link. No nominal type found for an inherent implementation. Requires a nominal type. Either implement a trait on it or create a new type to wrap it instead. Okay. That's a good lesson. That's a really good lesson. Cannot define inherent impl for trait outside the state where the type is defined. All right, so everything done outside your own owned types, presumably done via traits. So yeah, okay, I don't actually mind that being a thing. I mean, that's more or less how. That's kind of fair. Doing that in C# actually is kind of similar in the fact that you don't have access to any of the internals of the type that you're writing an extension for directly, I don't think. I'm pretty sure you have to access stuff through public methods. But you know what? It doesn't matter. The rules for rest are the rules for rest, so let's figure this out. Got to find an inherent impl for a type outside the crate where it's defined. Actually, that's probably a good thing. So actually adding implementations too far away from the code, like outside the crate. All right, yeah, I'm actually totally on board with that. Yeah. Okay, so hopefully anybody in chat can simply click on that link and follow through what I'm babbling and seeing on screen, because I'm pulling it up on my laptop. I didn't pull it up on my main screen. Okay, I'm going to leave that on my laptop for the moment. If I pull it up, I'll take a look at it in a minute. So that's why you need that additional trait, because when somebody wants to use your extension, they have to import to use it. Actually, that's actually a very valid point. The last thing you want is surprise interfaces into someone else's object. Opting into it is better than trying to opt out of it. Yeah. Seeing as this is a one file, no crate kind of environment that I'm doing here, I'm sure a lot of these rules are kind of outside my purview at the moment. That is a damn fine thing to keep in mind, though. Okay, so yes, let's do this properly. Let's try to create a new trait. Okay. Two different kinds of iterators. See if I can figure this out. So actually the function, at least the description of what the function's signature is going to be pretty much what it says on the tin, I think. Because all I'm doing is basically what in other languages would be describing an interface. It's basically the description of the operations that I have to satisfy in order to be a part of this trait or type class, as it would be in Haskell. And so gotta think this through. So because so let me see here. not functional. My zippable for iterator. And then I want to be able to apply, I want to be able to implement the actual result of the function in question. See what my compiler tells me, because I've done something dumb here. I'm sure, whoops. Whole pile of bad. Expected, found self. Okay, so gotta think this through again. In order for this to I think I can do this, yes, because self is actually the second type that I'm after. I think I want this binding to be mutable. I get the syntax horribly wrong until I start getting it right. Cannot find a B in the scope. Don't need this anymore, and I do need something like this. But I'm not actually addressing that top level thing here. The top level issue is expected identifier found keyword self. Okie dokie. That is not actually, that still has to be mutable. Both of them are going to end up consumed. In Rust, you have to name your fields when constructing a struct. Really? Is that true? Because I actually did not have to do it up here when I was just producing an ordinary function. Unless they have the same name as the bindings. Oh, that's interesting. Of course, because when I'm up here, I actually use the same. You know what? I like that. I'm totally cool with that. I'm actually very used to named bindings, again, from Haskell. But actually, I think C99 has that, now that I come to think of it. I haven't written much in that. But they started to use like named parameters and bindings. I can't recall. It's been too long. Anyway, don't mind that. Oh, and also, obviously, Python. I don't write a lot in Python because I don't like the fact that it's not very type safe, but it's got that feature, and I kind of like it. So, thank you. And this should be not IX anyway. That should be B. In fact, I'm going to demonstrate. I'm going to take this and do this. Oh no, IY. And I'm going to say sorry, I've got to look up, basically it doesn't work like the CPP initializer list, or how is that called? No, so that's totally fine. I understand, I understand the logic there. I do that in, like I said, I do that in Haskell. Whenever you're constructing structures there, you can do it in positional form. They do have that option, but I prefer when it's a formal struct and not a tuple to actually use the named parameter form because it's much more explicit. So I have no beef with that whatsoever. So very quickly looking up the Rust record structure initialization. That's totally fine. Yeah, okay, so So field colon and then the value that it comes from, except in the case where you say where the names are the same. So what that should imply then is ix colon self. And I'm going to leave the iy there because that kind of makes me amused that I could do that partially. I mean, I probably just this is more just to test the syntax. I probably would make those both explicit if I made one explicit, maybe. But just to get a handle on, what am I doing? Stack. Thinking in Haskell again. All right. Sweet. Could not find a type 4b at this scope. So let's take a look back at where I screwed that up. Because... Okay. Now here's a new fresh hell. This B is not being pulled into, or is not. This B is not being used as a scope for, from back here. And I mean that means that I could introduce a new B here, but then it's going to shadow the old one. So how do I avoid doing that? Sorry. Silent Z is full of useful stuff for me here. Impl, bracket, bracket, my zippable bracket, bracket. Oh. Oh, of course. Of course. Because impl itself needs a syntax of the... Yeah, I see. Okay, so this would be something like... I need A and B. Okay, I can work this out. Thank you for that, by the way. It would take me a while to find that. But I understand why. Because what I'm basically saying is here are the type parameters I'm going to need to describe this. This is the thing that I'm describing it for. Or sorry, this is the trait that I'm describing it for, which is going to use these types. So ultimately, I need something that looks like this for the general class of iterator. Okay. I should not have done something quite this crazy for my very first Rust foray. Well, not quite my very first Rust foray. Very first public Rust foray. But I love it. This is crash course. Trial by fire. Totally trial by fire. Okay, so if I had both of them in here, and yes, I know I could use where clauses. In fact, I may convert this to where clauses eventually, but I want to do it this way just for now. Why? I don't know. Maybe it satisfies the C template part of my brain. Way less control over... Well, I guess that's not true. C++ is starting to get into its constraints, concepts thing in order to do type constraint stuff, which is also very cool. But that's not what we're doing right now. So I need something like this where I say that this implementation has these type parameters that I'm going to need in order to satisfy the rest of it. This is what I'm building up for iterator. But now what I need to do is I need to basically tie self as being equivalent to A, because I don't think that's going to happen automatically. So this is, so hang on, okay, so let's just take this out for the moment. I want to think about this for a second. In terms of automatic type deduction, is it going to be able to... Sorry, I like how you are already using intermediate type system features but don't know how to initialize struct. Isn't that hilarious? Don't laugh! Don't judge me! You're absolutely right. Again, because I guess the reason for that, if I were to guess the reason for that, is because I'm more interested in the type system than I am the aggregation of structs, because frankly structs are the same pretty much everywhere. It is amusing. Yes, you're absolutely correct. I'm totally doing this backwards because of the part of this that I want to explore. And the actual struct part of this is not really that interesting to me, because every language has got its way to initialize structs and to create structs, and I guess I started to do so many languages at this point that I don't know. Anyway, be amused. It is amusing. Yeah, I'm more interested in the unification of the type stuff than I am necessarily the struct layers. Yeah. Yeah, no, I'm amused by that. It's a very valid point. Okay. So, do. Also, because I suppose I have done this kind of thing in other languages. I mean, it took me a while to figure out how to do this sort of cleanly in the C++ side. I'm actually pretty proud of that. And the Haskell side was a little bit, in some sense, a little bit too easy, because I could ignore a lot of the type stuff, because it does so much type deduction without annotation. Anyway, where was I? Back to... Yeah. Yeah, on that note, I'm laughing too hard to write code, so I'm going to take a quick sec to go grab myself another big glass of Coke Zero from all the way on the other side of the apartment. It's hopefully chilled by now. This announcement in no way endorsed by Coca-Cola Corporation. Totally laughing. All right, here we go. Let's get my brain back into the game here. So looking at this, basically, I have an A and a B, which I've sort of constrained to be iterators, because I know I'm going to need two iterator types, the one on the left and the one on the right. And then the composite is effectively, the result of that is effectively going to be a myzip, which itself is an iterator. So it's sort of a composite of the two types. So I need to be able to unify effectively A and self, and I'm not sure quite how to do that yet. I will figure that out. So, I need to be laughing at that for the next hour. Patterns aren't allowed in functions without bodies. Yeah, all right. Wait a minute, functions without bodies. That would be... Oh, because this isn't part of the type. Right, it's not part of the type, it's part of the binding. And so that... It took me a little while to get used to, but I'm kind of okay with that. Warning, trait objects without an explicit din are deprecated for iterator. Okay, this is because I'm trying to return an object for which I know the trait, but don't know the concrete type. Okay. This was previously accepted by the compiler as being phased out. It will become a hard error in the 2021 edition. Hey, that's fine. Help, specify the associated item equals type. Right. So this is interesting. I was actually reading up last night on the syntax for being able to control... not dependent types, associated types of a struct. I find this quite fascinating. That two ways to sort of control the I guess internal type constraints of some of these traits. Is to be able to, inside iterators somewhere is going to be an actual line that has something like type item and then some syntax describing what the item is, or creating an associated type for iterator internally. So if I did something like item equals item from the trait iterator must be specified. Okay. This is what I'm not used to. This is actually the one part of the code, a major part of the code that Silent Z gave me, where we had this syntax where it was like item equals t or something, and this was weird to me because this is actually controlling an internal associated type of the thing that's being made generic. It's not actually a formal generic parameter of iterator itself, I guess. I don't know how the best way to describe that. One of the best examples came from the Rust book showing like a graph class that had internal associated types of the node and edge subclasses, but they weren't required in order to refer to the type outright, which was a little weird to me. It's almost like they are implicit type parameters. In fact, they showed one with explicit node and edge type parameters as well as a counterpoint, and I understood why they made them internal only with this interesting syntax, so that you could, optionally describe them. Okay, that's interesting. Do I solve that second one before I solve the first one? Let me think about this. They might be related. I can't... okay, so... I don't even know if anything I just rambled in the last 2 minutes makes any sense to anybody other than inside my head. So there you go. Iterator A and B is equal for iterator... Okay, so let's quickly look up. Probably have this already open in one of these myriad of tabs, but that's the way we're going to go here. We're going to create another tab. Oops, that's not what I wanted to do. Rust iterator trait. Let's take a look. Yeah, there it is, type item. And if it's not specified in here, I presume it's meant to be specified outside, but notice that it's not iterator open bracket item close bracket. It's something I have to specify from the outside. So so would it be something like, for example, because we know that A and B are both iterators, A colon item, B colon item. How much is it going to whine at me for that? Don't know how to point you to that without exactly telling you. Yeah, that's fine. Let me fumble around a little bit. I will eventually, I'll eventually pull out my hair and get to where I need to go. Or I will come and bug you. I don't mind taking my time to figure that out. So this trait takes 0 arguments, but of course. So sorry, this is not what I meant to do. I need the item equals for one thing, because again, it's not pub trait iterator bracket. It's not. It's weird that it doesn't take type parameters, but it still requires me to set one of the type variables. This probably still won't work, but oops, let's. So the size for the values of type self cannot be known at compile time. Doesn't have a size known at compile time. Because, right. Could relax the implicit size bound on A if it were used with an indirection? Nope, I'm not going to be doing that. This could be changed to I colon size. Not going to be doing. I shouldn't have to do any of that. Trait objects without an explicit din are deprecated. Okay. The solution is one message above. I don't know which one I was looking at the time you typed that, so that doesn't help. But I don't think I want to be using trait objects. I actually want to be using everything should be known at compile time for all of this. So I'm missing a relationship here. It doesn't have a size known at compile time. So I meant my message and oh, ha! You missed the one with the solution. Okay, I think you were supposed to do blanket implementation. Okay, I think you were supposed to do blanket implementation, like impl my zippable for I, where I is iterator. Sorry, I will read that more thoroughly. Oh, interesting. So I'm not okay. Yes, okay. Or in your case, A, so the type which you're implementing is generic. Interesting. Because A is already marked down as being an iterator. Of course. Of course. Yeah, yes. Okay, That's an interesting distinction. I have to figure out... Okay. And actually, this wouldn't make any sense anyway, because... Okay, so let me think about where I was going with this. Even though this is wrong... okay, so actually, in principle, I'm not actually implementing it from this. I'm actually implementing it for any iterator that takes A's kind of item is what my thought, or is where I should have been going with that. What I'm trying to describe is, what am I implementing this function for? And in principle, that's what I'm doing. But that's not going to compile either, probably. So that just says trait objects with an explicit din are deprecated. And A is... and actually that would have to be item equals A dot item, even if that were to work. That's sort of implicitly what I was trying to get to. But that's not going to work. I got to think about a size for values of set type self. I need to get my Rust to the point that I know why it's saying each and every one of these things, and I'm not going to get there today. But I understand that it makes more sense to say, given that we deduce what A's real type is, and that's the left-hand side iterator, I'm technically wanting to do something like this. That's actually kind of what I mean to do. I don't need to say... I shouldn't... Yeah. So that's an interesting question. What kinds of things go on the side of the 4? I have to think about that. Because what I really want to do is implement it for a particular type. Okay. All right. Size of the values of type self cannot be known at compile time. Doesn't have a size known. My zip, self, and b. Okay. Okay. So, that makes sense, because in order to be able to return something, I mean, the message makes sense assuming that there's no size information, because in order to return something on the stack, in a lot of languages anyway, it has to be a fixed size thing. This is not living on the heap. And actually, I think one of the messages here is to like do a box thing. So if it were a dynamically sizable object or an unknown sized object, I want the box, which is a fixed size, on the stack, and the dynamically sized thing, or the unknown sized thing, whatever, to be sitting out on the heap somewhere. So given that this is not a size known at compile time, the box comment makes sense. Constraining it to be a part of to have traits on the items such that the entire structure is considered sized makes sense. Consider further restricting self where self is sized. Okay. This is at line 47, so it's actually specifically here that we're trying to describe okay. Size of the values of type self cannot be known at compile time, and the reason for that actually is the type self is bound here by way of, how do I potentially I don't need this, or if I do need that, then I need to be able to tie A to being self. So I'm not sure, but I have a suspicion you should replace self with A. All right. I mean, that does make sense, because then I don't have a free-floating parameter, right? But okay, so self, I think you mentioned yesterday, and I think I looked it up, being a keyword which describes the actual parameter for self. The thing that I'm worried about is the type of this parameter here. All right, let's just try that anyway. So, no method named myzip found for struct std slice iter in the current scope. Yeah, okay. So this is basically saying, on the left-hand side, we have this slice thing, because that's what VXS iter is generating. And it doesn't contain this method. Now, that's because I'm supposed to be effectively creating that method with what I have here. But it's not finding this one. That's fine. In the current scope. It's interesting that it managed to compile all of this. Oh. What have I done here? I am a moron. Thank you. Thank you very much. Everybody see that? Nobody saw that. Nobody saw a bit of that. Oh, hello. Oh, okay, so why is that not necessary to be mutable? Because it's not part of the type. Variable does not need to be mutable. Because none of what I'm doing here, it's not part of the type. It's part of the binding, or the part of the usage that it needs to go through. Right. I gotta think about that. And actually, I doubt that needs to be mutable either for the same reason. Functions never used my zip2p. Don't care about that. Okay, so let me. I gotta think my way through this because this is going to be critical to sort of me getting my head wrapped around this. So I needed the trait in order to be able to effectively add functionality to anything that's considered to be an iterator. So provided the thing is an iterator, I'm saying on the left-hand side, I'm saying I am allowing my zip to be defined. It's part of the it has the trait that it is in fact zippable. I'm permitting it to be zippable, and the way that it's zippable is this function. Okay. In passing the iterators that are relevant into this function, this is being passed in as a non. It's not a reference at all. It's actually being consumed by this. The left and the right hand parameters are being consumed by this and owned by the function and then by the zip structure. It is then later on during the operation of calling the various methods where they are see, back up in here, it is actually taking each of those iterators and slowly consuming them. Slowly iterating forward on them because the individual operations are mutable. They take mutable references. And so let me see this. They take mutable references on the left and right. No, this is mutable self. Gotta look at this. Also, I'm not sure what the implications in usage are, but you could specify b:iterator as bound on the myzip method. Okay, let me take a look at that. On the myzip method. I don't know what the implications of that are, and I'm not sure the implications are. So instead of the whole trait. Oh, I see what you mean. That's an interesting point. because I only really need the A side. That is a very interesting point. Because the only place I need... Okay, let me think about this. If I got rid of this, I would then have to have B iterator here. I mean, I guess the difference would be is that then I could eliminate B on all sides of here and just say that yeah. All right, let's try that out. That's a good thought, because what that would be is I could get rid of it there, and I could get rid of it there, and then say that it is basically be helpful in implementing more than one extension method with a single trait. That is a very valid point. I was about to say what this is doing is it's meaning that I don't need B to be defined for every method. I do need A because I need to be able to tie it into the left-hand side. I need it to be yeah, okay. Yes. Brain is slowly turning to mush. Iterator. And then that B comes from here, and that's fine. And so does that one. Self comes from the type of the function that's being called. Okay. But then self and A should arguably be the same type. Self comes from 4A. Oh! Yes, it does. That's the tie between A and self. Thank you. That's the mechanism for binding. Now that makes glorious sense. This, in fact, is unifying. That's the word I was looking for. Unifying A with self down here, because the very act of doing this implementation and providing a function for a particular type, that has to be what self is. Okay, let's try this. Let's try this out. I haven't actually run this yet. Everybody's now noticed, but cannot find trait iterator in this scope. Oh, it's because I just had a... Hang on. Let's fix that. Okay. All about the type unification. So that compiled. And just for giggles, let's actually give this a run, just so that we can say we've done it once and it doesn't explode. But this, by the way, is why I like super strong type systems like this. And again, I got this from Haskell, which is why I'm starting to love both languages now. By the time you get these things to compile, you can probably get the right answer, because the type system is so tightly. But note the capitalization plus Rust C flexing. Yes. I'm beginning to really like the warnings in this, but that's another great thing. The tighter the syntax on this, the more the compiler can help you out, especially when types are super concrete and you've got things like the memory management annotated in the types. The lifetime. I have encountered the lifetime rules before when I was having to fiddle with boxes doing my binary tree some time ago. I have to deal with that again eventually. I noticed how useful just the basic errors in here are once you know how to interpret them. But they're not quite as ridiculously wordy as all the template wizardry in C++, which is arcane at best. Did this before. I really should use PowerShell, but it's going to take a second as my virus scanner goes off, and I really should make an exception for that folder. But anyway, go do the thing. Yeah, so huzzah, does exactly what it says on the tin, which is fantastic. Okay, so I totally understand why to migrate that template parameter down in here, because I need A, because I basically need to do the for A thing to bind it to self. But I don't need B up here, because some of these things may not be based on a second type B. I mean, it's not going to be true for the zippable, but I can see that for traits in general, and that makes a lot of, for asyncs and futures. Don't worry, if you ever do parser combinators, the errors get spicier. Yeah. I tried to get into like some of the really complex, sort of the higher level stuff in Haskell, but the yes odd stuff was just a little bit beyond me. Like I'm not any sort of a wizard in that language either. I just got to get some serious appreciation for it. I got as far as starting to figure out applicative functors, and my brain started to short circuit, not because of their definitions, but the way that people were using them bloody everywhere. And I'm not sure that adds to the readability of the code. Maybe it does when you get really, really used to it. And some of the really deeper stuff with lenses and the like. Although I love the concept of lenses for immutable languages, that's great. But learning, for anyone else who encounters this stream, including Silent Z, part of the reason I'm digging into this particular stuff is, like I said earlier, I like higher order functions, and I like the composability of a more functional style. And while Rust is definitely, not meant to be a functional language, being able to approach data processing through this kind of scheme really appeals to me. Which is why I like the idea of ranges in C++. I will totally still use all the imperative and object-oriented goo in there and the template stuff. But anyway, enough of that. Composability is a good thing. Also being able to reason about your code. Where was I here? I was looking into... There was something about this that I was thinking about. All right, that's an interesting question. If you're implementing a trait for A, and A is always bound to self, is it theoretically possible to have something that doesn't take self as a parameter? Like, could you come up with effectively what would be considered a static method in here that didn't even depend on A? Like, heck, I don't know. System status. Can't remember what the data types are in 32. Give me a size. U size for sizes. Doesn't really matter what the parameter is. I'm just making this up as I go along, but I did something like U size. And that was actually part of the trait here. That, of course, obviously can't have. So this is going to just be 42. Would that even compile? Technically. Interesting. But it needs to be for a type anyway, so the fact that I'm not actually using A is kind of irrelevant. It just wouldn't be able to, I guess, automatically deduce that I was actually using this version of a particular function if it had the same name as something else, another trait or whatever. Yeah. All right, I'm going to not do something silly like this until I actually find I have a need for it. Methods without self will make the trait non-object safe, and it can't be used as trait object, same with generics. Interesting. I could kind of see that, right? Because then you wouldn't know whether you're implementing for A or Q or my soft slippers. That makes sense. Which is more or less what I say. You can't type deduce A. So here's an interesting question for you. If I did have something like that, could I manually bind the type A in a trait to a specific type to call the appropriate static implementation? You couldn't be automatically deduced from the function call like it is here for myzip. But in the absence of being able for it to automatically deduce it, could we manually state it? But anyway, in any case, I do take your point. I'm not going to do that, obviously, because I don't want to do that here. So, wow. Okay, so that was a big, long push down into figuring out how to implement what is essentially, I guess, at least from a C# perspective, would be an extension method for a... oh, that's lovely. That is just lovely, actually, now that I look at that code. Okay. And now, actually, what I'm going to do is I'm going to quickly... so I'm not sure what you're looking for, but you can call methods like trait method A, B, and A in that case can be self. Interesting. Okay. I don't know what I'm looking for either. I'm just testing the bounds of the type system. I didn't actually have a specific... I'll have to cross that bridge when I come to it. I'm going to pull up, actually, SilentZ's code, which I'm hoping you're still okay with, because you mentioned yesterday, the last one you did. I'm going to pull that up, which I, by the way, built, and it worked just fine. Let's make it a little bit bigger. And so we're going to take a look at the extensions that he wrote, just to see that I got anywhere near. Now, I didn't use a new mechanism, and I didn't base it on into iterator. So I did this in a slightly different way. So that's quite interesting, isn't it? My trait was named slightly differently, but that's no big deal. You did have the B type here, but that doesn't matter because that's fine. So that we just moved that down into the function. We just made that B here. So this is myzip where we had an I, where it was into iterator, iter equals B. So this is basically making it so... I think I needed it for into iterator. Which, interestingly enough, I didn't have to do, and I'm not entirely sure why. Maybe because it was already effectively an iterator? I don't know. Bonus constructor for zip from into iterators. Yeah. Oh, because I can move that B from the trait into, like I advised you. Yes, I expect you totally could. Actually, I'm more curious at this point about. So what you did was you basically, I just built up the structure instead of using a new function, and you supplied two parameters which were not constrained to being iterators. So you then see here. Oh, you did constrain them here. And then you constructed the zip saying a.into_iter, which means that A is not necessarily an iterator in and of itself. A is C1. But C1 can be turned into an iterator. Gotcha. I'm following. So you allowed the two parameters that were being passed into zip to be things that weren't necessarily iterators themselves, but that could be turned into them. But because we don't know anything about C1 and C2, inside of this thing, despite the fact that it's monomorphized, at the point which we're compiling this, we need to be able to have access to the ability to turn it into iterator. Through it into iterator. We need that call. To do that, we need them to constrain to a particular type, and hence they are constrained to into iterator. So we have access to that. In order for that to work, though, we need to bind one of the associated types inside into iterator to a templated type I1, which is unknown. Which is the target iterator type that will be produced by the call to into iterator, and that target iterator is then it's bound through the fact that it's the two input parameters here. This is clever. I love this. This is great. Okay, this is flexing right here. Like, it would take me another week to get to this point at least. I love this. Right. The mere act of calling new would say that the parameter A has to be C1, or is bound to the type C1, or the trait C1. C1 has to be constrained by being into iterator. This is a free-floating type parameter, but it is automatically deduced by usage. So effectively speaking, it's not that we're binding this to an already existing type, it's actually working in reverse. We are figuring out what I1 is because of the deconstruction of these types. We're figuring out what I2 is because of the deconstruction of C2 from its usage. That's fantastic. You have no idea how big a grin I have in my face. All right. Yeah, I mean, if I were creating, if we're starting to get into creating library level code, this is what I'd start to get into, we start to get into this kind of stuff. All right, so we're going to close that. I wanted to come back here largely because I just wanted to now come back to this, having gone through the whole process that I just went through to figure out why SilentZ did it the way he did it. And now I think I have a better understanding of sort of that pattern. That's great. All right, but the problem is this is zip. And I started out saying I wanted to get to zip width. This is going to go into a part 3 because I don't think I'm going to get into merge zip width. The minute I have this next piece done, merge zip width is a formality. I may get to it. But the next thing that I want to do is effectively this beast, which is I want to be able to do zip width, not just zip. So what I effectively want, because eventually I'm going to actually make my zip just defer off to my zip width. What I effectively want is not just A and B, but I want to also be able to store effectively the function that is going to be applied, effectively the lambda or the closure or whatever, that's going to be applied to the x and the y values to produce a result. And so I'm going to say that don't know how I want to do this, but I will figure this out. So this is the next step. The question is, here is my question. I want to look this up. I want to ask the question because I'm going to start to depend a little bit more on associated types, and I also want to get used to using lambdas because I like the higher order stuff. So here we go. Again, I'm used that I couldn't figure out how to build a struct when I'm fiddling around with this stuff. That's still making me laugh. So true. Rust, associated types in struct. Do that, associated types. Methods, come on, associated, come on, find me an associated items. Methods, types, associated types, please. Associated types. Here we go. Type, whatever. Except is it only in, so an associated type, our type alias is associated with another type. They cannot be defined in inherent implementations, nor can they be given a default implementation in traits. Okay. So I'm going to guess it's not going to allow me to do something like, probably going to balk at this, right? But it's going to be my zip with. Oops. Spend identifier, find type. So it's not going to let me do that. But it has to. It is doable as part of a trait. Okay. Which is fine because I mean I had to basically do it here, for example. So I can do it for implementations of traits. I can add associated types, and that's frequently done to basically have a queryable subtype, I guess you could say, within the trait. I'm a little surprised you can't do it for structs that are generic, like for generics in general, though. That's interesting. Improves your readability of code by moving inner types locally into a trait as output type. Syntax for the trait definition is as follows. The trait contains. So... See, I find this interesting. In be defined in the trait via the type keyword. Note, type in this context is different from type when used as aliases. Instead of having A and B listed here as part of the generic parameters that are required to go into contains, they're listed as types inside. I find this interesting, and I need to find out the conditions under which it's most applicable to have them listed as type parameters going in at this level, and when they aren't. And one of the examples in the Rust book, again, showed that graph example. So you could create the trait. You could define the trait without them at the outer level, but they're defined as associated traits at the inner level. I don't know what the difference is or what the total, because they implemented it both ways in the book. I'm wondering if there are broader implications of having them internally. Now, obviously, you can only do this on traits, or it looks like you can only do this on traits. It doesn't look like you can do this on... here we go. No, the functions use a trait contains are no longer required to express A or B at all. So here we go. Without using associated types, this makes sense to me. Like this is the way I would do it in C++, actually. All of the free type parameters would be listed up front, and then you would basically use them internally. But using associated types, you can say that C is part of contains. A function that uses trait contains are no longer required to express A or B at all. So that's interesting. By saying that the container type C in this example is part of this, sort of follows this trait, there are these other types that come into play using associated types. Let's rewrite the example from the previous section. I'm going to have to look at the previous section in a minute. So, those types can be specified, those internal types can be specified on a case-by-case basis, because for container A and B are set to be these types. They're bound at that point to these types conditionally, though, because for a different implementation, I could bind these to something else. So they're associated because they're sort of based on substituting. They're based on what this trait is being implemented for. It's interesting. I would totally have done it this way, which is one of the examples they also give in the graph example elsewhere in the book. Okay, I'm going to have to think about what that means, because if I can push, I can't do it for struct, so I actually need, okay, so I want to be able to create a zip. I'm going to need a type that describes the function that I'm going to be. So it would basically be, say, f, something like this, right? I want the function to be applied to be part of the zip, because every zip will be applying its own function. I'm going to implement it this way. There's probably no other ways to do this. All right. Oh, except that's the myzip. I don't want to alter that one. Pay attention, Mike. Codeweaver, Mike, whatever. Probably see my name float around in other bits of my interface here. So, pay attention, Codeweaver. There is a test afterward. All right. So doing that, I need to be able to. So here's an interesting thing, though. For my zip, I actually want to, can I actually do this? Let's actually constrain this, because I don't want this thing to contain just anything. I don't want anybody just using this. So let's just do A iterator, B iterator. And let's just make sure that that compiles while I'm here. Constrain everything so that nobody can screw it up. A is not an iterator. Required is, this is bound in my zip. This is at line 32. Oh, no, at 50. At line 50. Yes, here, actually, my zip 2p. But I'm actually going to get rid of this, because I'm not going to use this anymore. So bye. So that being done, and it just compiles. So that's fine. I actually want this. I don't want this to contain things that aren't iterators. So this is actually going to be A, and just for giggles, let's use, can I do this? Let's see if I can remember how to do this. Where, see if I can introduce a where clause. Right. Yeah, so Rust, where clause. Let's do it. Where clauses, where, yes. And actually, they recommend putting a where out here, so I will totally do that. Where, and this is all separated by commas. All right, so where A is an iterator, where B is also an iterator. I can't spell apparently today. Is that muscle memory? All right. Do I like this more? I don't know if I like this more. But I think I am going to like this more because the next thing I'm going to do is actually say what f is. And f is going to be bound to a function type. If I go far enough back in here, that's methods, because I know I was reading about this earlier. Bounds. Apparently not. Oh no, here we go, anonymous functions, right? Specifically, I want to make sure that this conforms to, I guess, a mutable. No, this is not going to be. This is going to be something where I am going to take values and produce a new value, but I don't want to consume the originals. So this is going to be a function. Ultimately, it's not an fn once. Yeah, here we go. Fn once consumes the variables it captures from an enclosing scope. To consume the captured variables, they must take ownership of these variables and move them into the enclosure when it is defined. Okay. I don't want to consume the original values. I don't think. So, and it says that when you create a closure, Rust infers which trait is to be used based on how the closure uses the values. This is an interesting thing I find about this language, and actually, I find it very appealing in a way. Built-in compiler operations use traits just like the programmer would, and so there's I guess, a uniformity to the way that you discuss what the compiler is going to do versus the kinds of traits that you would develop. Like, for example, there's no mention of this constraint, this trait, when you're building a lambda, as far as I can tell. Like when in all of this example code here, in creating closures here, for example, none of this necessarily describes a trait directly. Whether that's a good or a bad thing, I don't know. For example, the application of move here, as I've discovered, changes the trait associated with the type of this lambda. Yeah. I don't know where to go with that sentence. I guess I think I appreciate the fact that when I go to ask the question, what is this thing's type? I like the fact that it's using a trait, just like user-defined parameters, in order to describe, or user-defined traits, in order to describe what the type of this thing is, rather than having to have some other complicated way to match against this particular trait. Right. But what I need to know, at least for this, is how I'm going to store this thing. What I really need to know then is, more broadly, they go and do something very clever here by creating sort of a lazy evaluation of, here we go. This is the kind of thing that I want right here. They do this neat thing where they're sort of implementing cached values as part of lazy evaluation. This is how you would basically implement a thunk for the kind of lazy evaluation Haskell does in all of its variables. And it's a common paradigm for creating sort of lazy evaluation across other languages. I like that we use it as an example. It's not sort of the easiest example that I would use as a go-to in a tutorial book, but I know what they're doing, so I'm okay with this. So this is basically what I'm doing. I'm doing something like this. So what I actually want is that my f is constrained to be not from U32 to U32, but it's actually a Here's the question: how do I, if fn is a trait, how to create a 2-parameter version of this? Because I'm going to need more than just 1 parameter. I'm hoping, and I know there's no overloading on functions, so I'm curious as to what they're doing about overloading on types here. Okay. So, Rust, closure of 2 parameters. Pass multiple args to a Rust closure. As an example, yeah, let's move along. Really, currying, is that the best we can do here? So call it as, so this is just doing a fold, so that's like, well, that's a just basically an aggregate function. But that's not the point. The point is, fn fold implements function u32, u32, arrow u32. So is there overloading on types, or is there some wizardry going on here? I mean, I appreciate the syntax. So this is going to be taking I technically don't need to actually name the okay, how do I state the return type of a call to this particular function? It's just going to be C. So that's going to be pattern matched, which basically means do I actually need how am I going to state an output parameter for this, given that I can't have an associated type inside of this structure arbitrarily? I need to possibly have a trait to do this for me. I mean, I could do that, and then as free variables, f would be bound by okay. I mean, I can start here. Okay, so, right. We'll take multiple arguments in a closure and print them. Right. More examples. But unfortunately, their example here, where t is some function right. So their T is being described as their function. So this is what I'm doing, but they're basically just doing a U32 to a U32. I need something more broad than that in order to make zipwidth actually viable. Okay. Not entirely sure how to look this up, but let's see if I can mimic the general structure of what I'm doing here. So what I'm going to be doing is, this is an iterator for my implement the next operation for my zipwidth ABFC. And I need to have the same constraints on this. Where? No, I did the where. And I need to have an additional constraint for, so we are going to take these out of here because now we're going to start having much more complicated where clauses. See, I'd like to not, because C is a dependent type, I'd actually like to leave it out of this, but I'm not sure if I can. Yeah, all right. You know what? I may figure out how to do this with a combination of a simpler struct and some sort of trait in order to be able to have that that type. To be able to have C as a, yeah, okay. Not sure where I'm going with that sentence. I'm going to leave this the way it is, fully specified from the outside like this. I'm going to see if that compiles in a second. What I need, though, is to be able to duplicate all of this. The type of this is of item. Now this is an implementation of a trait, so I can have an associated type. So the item in this question is in fact C. Okay. I'm hoping I can trim some of this fat out in a second here. So in next, if we have two items, we have self ix next, self y next, so that's the same. But instead of doing this, what we're actually going to do is say, we're going to say f of x, y. And this is no longer a tuple, this is actually calling a function. And I don't want this to own or consume the values, although, so let me think about this. For primitive types, it's not going to matter because it's just going to keep doing copies everywhere because it's just like integers. It's just going to make copies of them anyway. But I don't want them to do any I don't want them to do any consumption logic for anything that's not an integer. So let's see if we can make that work by, well, let's see if this compiles to begin with. So my zipwidth where, etc., etc., etc. So let's start there first. It's going to ynat cannot find function in this scope. Because why? Because Do that borrowing copying decision to callers. Interesting point. I will try to remember that. I still haven't figured out. I guess I have to start figuring out where those decisions matter. But because this is an interesting point, because so the next operation I'm pretty sure is is doing some x and some y. I think these are not borrowed. No, these must be borrowed references. I'll have to think about that. It doesn't matter. I don't know if x and y are copies of anything at this point, but I can say that I can defer the responsibility of whether or not to consume the inputs to f for the person who implements f. I don't have to make the decision at this level for f anyway. It's a good point. And of course, this has to be self.f. So no method named f found for mutable reference. Huzzah. I think there are some borrowing iterators that are not possible to express without generalized abstract types. Is that GATS, which is a nightly feature. That's so okay. So borrowing iterators. Okay, so iterators. I'm guessing by definition generic associated types. Sorry. Yeah. Sorry. Still not up on all of my seriously deep type parlance. I took a stab. Okay, so what that implies is that iterators, generally speaking, in Rust do not do borrows, which would kind of make sense, at least for integers it wouldn't matter. And for any boxed types, it wouldn't matter because the boxes are trivial to copy. Okay. Okay. My brain is still starting to turn to mush now. I've got too many things floating through it. Okay, so to call the function stored in f, surround the field access with parentheses. Okay, so no method named f found for mutable reference. And why is that? Because self is mutable, which means that f as a function why is this not allowed? I have to think about where I am. So no method named f found for a mutable reference. So it's just a syntax thing. To call the function stored in f. Oh, I see. That's a field and not a method. Okay, never mind. I got it. Okay, yeah. It finally hit me. I kind of get that. Because what that's implying, like what my way of doing it is implying is go look up to see if there's an implementation for my zip width where f can be called with self as that first parameter, and x and y. But that doesn't exist. That's not what I'm doing here. I'm not calling a method f that has been implemented for my zip width. I'm calling a method f that is stored inside of my zip width. Got it. That now totally makes sense. I can cope with that being the syntax involved here. That's fine. Huzzah! All right, so what do we got here? Mismatch types. So expected type parameter A found associated type. Okay. It's going to be exciting. Mismatch type. So expected type parameter B found associated type. Okay. Hang on. I'm going to clear that up. Let's try that again. All right. Sorry, FN, AB, but A and B are iterators, not their items. Yes. Thank you. I see what I have done here. Because these functions have to be defined effectively as being this. Right. It's hot. I swear it's just the heat. I mean, I'm probably still not there yet, but I'm probably... Oh, hello. What the hell? Wow. Okay. That worked. Okay, so let's continue implementing this. Well, okay. Did not expect that to work. Okay. This all works. I don't like the fact that I have to specify both F and C here, because this should be derivable from these three, but I need to be able to express that somehow, and I need to figure that out. I need a way to force C to be deduced. Or force F to be deduced, because I could force F to be deduced from A, B, and C. I don't need both. So I want to find a way to strip that down. But I'll do that in a moment, because right now this actually still works. Or it compiles, as we see here. So, okay, so I will get there in a second. Jeez, if I didn't have silent Z here, this thing would be about this stream would be about 1,000,000 times longer. You know, it's ironic too, because I would have fallen into the same trap implementing this in C++ if I didn't know where I wanted to go with the type system there, and eventually I would have fought through. I think it's mostly because I'm not used to the error conditions in Rust, and I will get better at that, but that's interesting. I don't know. Let's see where this goes. So, what am I doing here? I am grabbing this because I'm basically going to create kind of a clone of this. So is my zip withable. That is a terrible name. I'm going to use it anyway. Create my zip withable. I only need to worry about the A iterator because this is basically just, I don't need, to worry about the B iterator, and I don't need to worry about the result, because all I'm really doing here is saying, how do I create one of these when the myzip is in between. So when myzip is taking self on the left and the other type on the right, and all that's doing is deferring off onto the so this is myzip with. I'm gonna have to do a whole bunch more of these kinds of programs in order to get really comfortable. So this is going to be actually myzip with. Actually, I'm still going to need. I can actually get away with. I'm going to take this out of here because I'm going to use the where syntax. But I'm also going to need. Let's stick this up on here just to be canonical. B is from iterator, and then we're just actually going to grab this. All of that, but we need to bring in B, F, and C. Still need to find a way to deduce F from C or F from A, B, and C, or C from F, A, and B. So I don't have to have this sort of extra parameter in here. Okay, so to continue on this is going to be the extra parameter here. We're not going to have the B iterator here. We're going to have the where. And then we're going to copy all of this. This seems like a lot of repetition. Wherever there's repetition is probably a better way to do this. But let's get it working first. Right, so we're bringing in F for myzip with ABC F. See, I'm doing the parameters in different orders now. ABFC. All right, that's fine. I'll do ABFC. ABFC. B is the iterator, F is etc., etc., etc. And so this has to be. So this is 4A, which means that that's the self property that's coming in. That's fine. So this is B, F, and C. Yeah. Right. And then F, which we don't need to mark down with any annotation because it's the same as the struct name. And I got something broken here. This struct takes two generic arguments before we're applied because I didn't say myzip with. That's fine. Here we are, we're getting close to multiple clickable items in scope. My.zip, that's because that should be myzip with. No overloading allowed, which I am, again, completely on board with. There we go. Ha 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 ha. All right. So, with that in mind, what I now want to do is I'm going to comment out this because Actually, I'm going to comment out all of this because I'm going to re-implement. Here's what I'm going to do. Comment out this. Comment out that. Thank you. Comment out this. Because what I really want to do is I want to copied it before commenting, but whatever. What I really want to do is I want to implement my zip in terms of my zip width, because then I don't have to write another test case temporarily in order to. No, thank you. Thank you. So what I really want to do is simply, basically the result is my zip width self by y and now the new function in question, which is take an x. I think I can do it this way: take an x and a y, and produce. I don't remember the syntax. That's okay. That's what we have. It's not where clauses. It's not associated types. Come on, where are we here? Defining instantiated structs, because that's just still funny. Methods, bounds. I will get there. Where are you calling functions with? How do I actually? Don't need to be capturing environments in this case. Although, always awesome. Oh, I don't need an arrow. It's basically just the expression, or I presume maybe code in parentheses, but in this case an expression will do just fine. So x and y, and we basically want just x, y. How hilarious will this be if it works? Of course it doesn't work, but that's all right. Cannot find my zip in this case. It's supposed to produce a my zip self AB because I don't have that anymore. What I really need is to say that it's actually going to produce. Now I could wrap this up in a my zip, which then takes a my zip width, but not going to worry about that. We're just going to go straight to my zip width, which has self B tuple containing self item B item. Again, this looks ugly. I wonder if I can pull oh, there you go. Thanks, Silency. Sorry I didn't catch that before I found it in the excellent. All right. Totally didn't work, but that's all right. Here we go. Unexpected closing delimiter, because things and stuff. Oh, I did not need that. That's right. All right. Getting closer. All right. What do I got here? Cannot find my zip. Oh, because I'm still doing that, because I need that trait to be slightly different. Okay, that's fine. Rather than wrap it up in a my zip, I'm going to comment that out like I should have done. Copy it first. Oh, it's getting crazy. My zip width AB. Oh, good heavens. This is going to be the interesting thing, isn't it? How do I state this next bit? So, want to become famous by followers, primes, and no, please screw off. Right. So, I kind of need to be able to do this, and actually, actually, no, this type is known. But the thing is, can I do... I should be able to do a where in a function, right? So if I do ABFC, I do basically where and then put in my... I keep wanting to put the where on the lower line. I guess because I do that way in Haskell. It's fine. I will live with the convention. That's a me thing. So I need basically to say that I specifically so this is going to be a item, actually self item, right? No, why is it with AB? So actually this needs to be self? No, it's a. Item. Actually, I could do this, right? I should be able to do C is equal to A item, B item. And then this just yields C. And it's a little bit cleaner, maybe. But if I do that, then I also need to duplicate it. Where totally loving this brace style here. Suppose I could, nope, that's not what I wanted to do. I suppose I could basically indent this to here and here. Like that either. Don't know what I'm gonna do with that. Whatever. All right. $105. It doesn't like what I did at 105. How do you feel about auto formatters? Rat has rest form. I'm totally cool with auto formatters. Like, there's a point at which I would have been annoyed by it, but at this point, I'd rather, be canonical with it. But I don't want to right now. I don't want to have to fight with it while I'm editing the code. I'll have to think about how I. Okay, let me rephrase that. What is the process for using an auto formatter on an externally modified piece of text like this? I presume just a command line option, which would then auto format and write it back in place. I presume that's the way those things go. Rest function where clause. Oh, you guys can't see that because I didn't drop that into here. Where clauses, so bound can also be expressed with where clause immediately before the opening curly bracket rather than at the type's first mention, but this is for implementations and not for functions. Not for traits? No, it should be. I would have thought I could have done that. I think line 110 is the problem. What did I do on line 110? It's specifically saying here, though, that line 105 is the problem, which is here. So perhaps a where clause can't follow a function definition inside a trait? That seems odd. No, I think I'm missing what the syntax error I'm having here was. Parsing this item list, it was expecting trait myZippable, so it, well, parsing the item list here, yeah, it's line 105 that it's complaining about. Yeah, it's not clear to me if I'm allowed to do where clauses in the context of a function like this. It's not clear to me precisely why this is not working, but maybe it's not allowed there. Basically expressing bounds on the parameters, I would have figured. Like I can take this out of here just for giggles and put it inside here, where B is an iterator, just to make that more uniform. I should do that actually. Where but that's not actually going to improve matters. Oops. It specifically doesn't like me creating a tuple type out of these two things. Where clause, Rust, where clause, after function. We're going to comma after the items like A : item, B : item. Did I not do that somewhere? Like add an extra comma here? Not entirely sure what good that would do. Oops. No, it's specifically saying that it doesn't like that first comma for some reason. For one item enums. Yeah. Attach where clause. Is it possible to attach a where clause to a generic function? One of the generics has a lot of traits. Yeah, it seems like it's possible here. You have some badly commented code above. No, this should all be properly commented out at this point. think. First, at least I'm not seeing it, and the first complaint is literally here. Peculiar, huh? Yeah, this is interesting. Ignoring the C# example that they have there. They have a function foo, which takes no parameters, I guess implicitly returns unit, because it's not specifying what it's returning. But it's saying it's doing a where clause, and that's fine. And that should be similar to what I'm doing here. So it doesn't like the tuples, perhaps? What version of Rust C do you use? Pretty recently, because I reinstalled it. Rust C version 1.54. Fairly recent because I updated just before I embarked on this stream. If this is a new feature specifically being attached to a zip, that would be being attached to a function, that would be kind of one thing. But this this example is coming from, I guess, yeah, May of 2019 is where this example is coming from. I'm doing something stupid here. Like one character misplaced somewhere that I'm not completely aware of. Hello, I'm new to Rust. So take this with a sizable grain of salt. But maybe the issue is that you're using a tuple, which as a type, as a trait in your where clause. That's an interesting point. That is a very interesting point. Did I do anything like that anywhere in my previous examples? Okay, so this was a trait that combined a couple of things, so that doesn't fit your example, or your your comment, which is valid. You're right. I'm not doing that actually anywhere else. Okay, that is a fair point. And it doesn't bother me that I can say that is a very interesting it's a very interesting point. I'm totally new to Rust too. Yeah, because I can do this. That's fine. For example, and then chop this out and see if it behaves better. But I'd like to factor that out. So what I'd really like to be able to do is do a type alias rather than I guess a constraint, because it's not really a constraint, is it? Except then I don't need. But see, then the thing is, and here's the ugly bit. I don't have. See, I would have to do this because I no longer have access to C. All right. That is an interesting point. I believe the fn trait is used for some function that takes types x and y and returns z, which is why the tuple-like syntax works. Yeah, I guess my problem is that I have a situation here where in order to construct this guy, I need a type C. Which from this point of view is just a type, so I don't need to do I don't need to define it. So that's why that works up here. That's fine. I was trying to find a way to avoid having to specify C. Like I'd like to be able to actually be able to use, I guess it's not really a constraint. What I really want is a type alias as a substitute for this, so I just don't have to paste this guy in everywhere. I will have to look at ways to do that sort of thing. Oops, that's not what I want to do. Where's my compile? All right, so let's see if that gets us any further. Cannot find F in this scope. That's at 106. What am I doing wrong here? Oh, because I don't have, no, I do have A. I do have A here and here. Because I don't have, because I'm being dumb is the reason I don't have that. Actually, that's the reason I need to have this here as well. Can't function my zip width. That's fine, because it's actually not done that way. It's done this way. This struct takes 4 generic arguments. Of course it does. Self B F. There we go. Associated type item is not found for self. Oh, that's because it's actually to think about this for a minute. A is known to be an iterator, so it should have an item. So I think you just need to declare a type alias in the impl block. Oh, for the for these guys, maybe. Except the problem with that is I can't. Oh, sorry. In here you mean the problem with that. It can't propagate. You would have to do self as iterator : item. Oh, interesting. Yeah. Okay. Okay. Though. Okay. So the problem with that is self is absorbing this, but I'm not actually expressly saying. Because okay. It can't propagate that. So that's interesting. Yeah, I could do a : item. Yeah, no, that totally makes sense. Like I could do this. But that's interesting because what that's saying is that A and self, so there is no direct, is there a direct binding between A and self? Yeah, not binding, a direct unification between A and self. It suggests that that's not the case. It suggests that self's type at this level is the type of the self parameter itself, but not it hasn't propagated all the properties of A, even though A has to be self. Okay, that's interesting. Okay. Self can implement a different trait with different associated types. That could be named the same. Ah, scoping. Yes, right. Because self is... Okay, so self... I see. That's probably why it doesn't work. I think I agree. I'm just trying to wrap my head around the fact that, see, to me, there's no direct association between A anywhere in this and self, except for, like you said before, we're doing this for A. So ultimately, the self parameter has to be A, except it is in fact a separate type. Right. Because the only thing we know about A is that it's an iterator. Right. Right. I can't use self because self is a different type, and even though it has been constrained effectively to be an iterator, we can't use self to get at item because self itself doesn't necessarily contain an item, or it could contain a different kind of item. Okay, I think I'm following that reasoning. Yay. All right, hang on. Let's slowly wrapping my head around this. All right, so here we go. Mismatch types, because of course it is. 119. Oh, it doesn't have a return expression. There we go. Nope, I had done that wrong, but hang on a second. Mismatch types. The expected type parameter f found closure. Oh, that's going to be exciting. Right. We're getting closer. Every closure has a distinct type, and so could not always match the caller chosen type of parameter f. This is where things are going to get awfully interesting, because I would have thought it would have... Okay. Consider specifying a type arguments in the method call. All right. All right. Every closure has a distinct type, and so could not always match the caller chosen type of parameter f. Because that is rubbish. That is totally rubbish. I need to actually specify what f actually is from not from the outside. This is actually going to be... See, now what I need this guy's type as the parameter. Again, okay, so... I need a type alias, again. Hey, learning Rust. Since? Yeah, hi, SPJ. That's a hard question to answer. It's not the first time I've written something in Rust. I wrote a thing involving, or starting to write a thing in binary trees about a year ago, and then I put it down, and then I let it rust. See what I did there. I really only started writing this thing yesterday. I've been reading up on it for a little while, and I got a pile of other languages under my belt, and this is my latest attempt at an acquisition, and I took on a really tough project because I'm insane. At least tough for a first go. I have some C-like languages under my belt, C and C++ and C# and all that stuff, and I have a lot of strong type stuff under my belt, Haskell in particular, and some other languages besides, and I decided that I was going to write something in several different languages. And at the beginning of the stream, if you have a chance to go back and look at it, I wrote a Haskell, C++, and C# version of a particular kind of zipper function for lists that I want to now implement in Rust. And so this is requiring me to learn how all the type unification stuff works in Rust and the trait stuff, and how it differs from when I do it in Haskell, as well as apparently learning how to just build structures. See gag earlier in stream. So that's where I am. Literally, I guess, writing this code since yesterday. Right. So the problem here is I want F. So I am literally creating this guy. The functional type is not coming from outside. I need the type of this expression, but I need it up here. This is going to get really, really gross, because so actually, can I do, all right, so, Rust type alias. Yes, I could do, try a concrete function type instead of F. That's an interesting point. Okay. Okay. Well, except that... Okay. Thanks. You're more advanced than me than I tried to learn it from the book on the website, but because of lack of time, I gave up. I'd like to retake the task at some point. It's a fascinating language. The very, very basics of it are not too different from like a lot of C-like languages, except that I would say the things that you have to get over, ignoring the generics part of it, and I'm getting really heavy into the generics part of it because that's the bit that kind of really seriously interests me right now, because of the type of problem I'm solving. The big thing that you have to get over is probably the borrow checker, the thing that does all the memory management for you and makes sure that you don't bite yourself. And that's something you don't see in almost any other language. So that's the big thing that will trip people up. And that basically says somebody always has to own data. And you either hand off that ownership or you hand off a borrow to it. But if somebody else borrows access to it, there's a limited number of things that they can do to it. And there's also the fact that the default nature of a lot of the values in Rust is to be immutable. So once you set a value, you can't change it. I mean, you can trivially mark something as mutable so that you can go and change it just like every other variable in most other languages. But that's not the default. So the language sort of trains you into thinking about, how do I write this so that what I'm really doing is taking data, putting it through a set of transformations, and then outputting the result without sort of altering stuff that you're already holding on to. And getting into that mindset has a lot of benefits for things like avoiding avoiding race conditions in various kinds of threading, and being able to massively parallelize things and stuff like that. Because mutations are the cause of a whole pile of problems. And in a lot of cases, the main reason you're doing mutations on things is loops and stuff. And there's ways to do loops and stuff without having to do mutation on your own. That's something I picked up from Haskell than I picked up from Rust so far, but I think the principle still applies. Yeah, it's an ML family dressed like C++. Yeah, I kind of agree with that. Yeah, I would even go so far for me as to say it's Haskell for C++ programmers. I'm going to get both sides shooting me for that statement. But I find the idea of that. I'm taking a break to ramble because somebody asked me made an interesting question or point. I like the idea of the borrow checker for a couple of reasons. First, not a lot of if you're wanting to design a zero cost abstraction kind of language where you don't pay for stuff you don't use. The garbage collection of a language like Haskell can seem to be problematic. Super efficient. They did it really, really well. And I think you can make a good, even some good near real-time systems using it if you're careful. But, and for a lot of cases, you don't care. You're just processing data. You don't care about having to garbage collect some stuff because you're just running on data, processing data. But avoiding garbage collection requires classically for you to do all your own memory management. It's hard to avoid, and Rust is doing it, and it's kind of awesome. I mean, there's always going to be edge cases, but being able to manage your memory and who owns stuff so that you can properly destruct things when they're not being in use, but not relying on garbage collection to do it, requires you to trace who owns stuff and to know that when something is no longer owned, it can be deconstructed right there. That's kind of a cool superpower, but it's not a lot of you see in a lot of other languages. Yeah. Anyway, yeah. Well, my time I did C, but no C++. Also did some Java. Yeah, so Java sort of took the stuff that you were starting to see in the C++ universe and said, let's add garbage collection to avoid the memory management issue. That's kind of the way I see Java. Oh, well, also the, write once, run anywhere because of the virtual machine, which was a cool exploration. But I'm not going to talk a whole lot about Java because I don't write a lot in it, and I'm going to leave that for people who really love the language. So that's cool. But I wrote some stuff in Java too, did a bit of that back in university, so, and some web stuff at some point. Good language. Where was I? Back to what I was trying to do. I was trying to figure out the types here. So, expected type parameter f found a closure. Right. So, instead of trying to implement f as a trait here, being produced from the outside, I could try to do Silent Z was suggesting a concrete function type where I take a function A item, B item, producing the tuple A item, B item. And of course, that would be the same here. Really don't like all this repetition though. I gotta figure out either type aliases or some way to say, give me the type that this function call would produce, sort of an invoke result. To figure out how to do that. Cannot find f in this scope. At 106. Why? Where are we doing this? Okay, I don't need this. And I arguably don't need this. Oops, that's not what I wanted to do. Deleted too much. That, please. Like, eliminate the F type directly. Ha! Look at that. Beautiful. I seriously need to just copy all of SilenZ's Rust brain power into my own. I'm just going to have to do it the hard way. So that's cool. And that makes sense because basically I'm instantiating very specifically instantiating. I'm unifying the myZipWidth structure with a concrete type as a substitute for F instead of trying to do it as a trait. Wow, my guess was 50-50 that will work. That is really cool. I presume, though, that that's not going to work when there's any sort of abstraction. Like, that has to be a function with concrete types for that to even make any sense. Like, I don't think... well, except that A.item, or A::item isn't. B::item isn't. This type is derived. Okay, so when... That is kind of awesome. I'm trying to think like the compiler, and I'm not... Yeah, I'm surprised myself. I'm not... yeah, I'm trying to start to think like the compiler, and I got a couple of objections to this. First of all, that signature is getting a little bit horrific and repetitive. And I'd like to find a way to collapse that. Here's a thing for you. One good reason to move B as a type back out to the outer scope is then I could create a type alias in here as part of the trait, I think. And then I could use that to define the function. Whereas when it's in here, by the time I need the sort of, not that bit, type 2 tuple AB equals FNAB arrow AB, but it doesn't help much. No, it kind of doesn't. It's a little bit better. I also like, though, that a type alias itself can be templated. That's kind of awesome. That's actually everything can be... can take generic type parameters. I find that like the universality of the syntax to be quite awesome. Okay, so let's actually, you know what? Let's run this thing, because what we should have now is we should have the same zip operation we just did, except we're deferring off to ZipWidth to do the actual work. And that's very much where I want to be. So, come on. There we go. Run. Again, I love languages where by the time you even get them compiling, you're almost certain it's actually going to work, because so much of it has been sort of statically analyzed. God, I love that. That's just, look at that. Oh! That's great. That's absolutely fabulous. Given that we have gotten to this point, implementing my actual merge zip that I was pondering is actually kind of a formality, so I'm not actually going to go there yet. I kind of want to play with this just a little more to see where I can sort of trim down the repetition. First of all, here's the thing. My ZipWidth takes both F and C, and I kind of don't want it to be. So where can I actually add a type alias? Like, where am I permitted to do that? Because it would be really nice if I could eliminate one of F or C, right? This is silly. It took kind of long. Sorry, what? The execution? That's because my fire scanner probably saw the executable I was running and said, what the hell is this? So, can I effectively deduce C instead of needing to have it passed into my zip with? Because the only reason that's here is to auto-deduce F. No, not auto-deduce, actually. I have to explicitly specify these. I have a feeling you can't do better than this. Yeah. Because you can see, right? I'm not just blowing smoke here, that effectively C is a derived... I'm going to use that term wrong, but it's a type that is derivable from the other type parameters in here. It shouldn't need to be specified specially. It's kind of unfortunate. Yeah. Actually, it doesn't... I guess... Okay, because... So this I'm probably not going to be able to... I've never seen something like F. Yeah. I need something like F return type. But the thing is before I define F, the return type here is not known. In order to do that, I actually have to sort of have a function variable, a callback, whatever, a lambda, and as a value, and I have to say, what if I use this function value and give it parameters? What is the result? And in C, you have something like if you have a lambda where you have like just to give you an example, auto f equals, let's see if I get the syntax right. So something like, I don't know, int a, int b. Actually, I could even make those generic parameters in and of themselves, but return a plus b just as a substitute for a plus function, for example, or a squared plus b, let's say. It doesn't matter. Let's just make this a little bit more non-trivial. There is something where I can basically say I can say, if I know what F's type is, not its value, but its type, so I could do something like using F equals... Don't ask me what all this syntax is, it doesn't really matter, but just for those who do actually know C++. So I could do, decay, and I need to pass in the decal val. So decal val just, or decal type of F. And the decay just removes levels of indirection off of it, or constants, and a bunch of other crap. So, and I do that, and then I could say something like return type is equal to std invoke. I think it's invoke result of F, something like this, and I could actually get what the return type is without just based on the value, the type of the value of the function. It can deduce what the actual return type is. It can just go through all the type analysis. Because all that type information is available, and it has to be available in Rust as well, I have to imagine. Obviously, there are other ways you could do it, because if your lambda system, for example, if the lambda types, if the fn mul, and all those traits had a call on it, or had an associated type which was a return type buried in that trait, that would be kind of interesting. Let's actually go and look that up, because I am kind of curious. Rust fn trait. Let's go actually see what's in here. But you're probably right. Using an fn parameter. Calling closure. This trait is not to be confused with function pointers. Fn is automatically created by closures, which only take immutable references, etc., etc. Yes, I know that. but I actually want to know if there's anything in, so fn args is pub trait fn args. I don't know what the syntax is a subtrait or something. I don't know what that syntax is. I'll have to figure that out eventually. It'd be nice, though, because it's a trait, it would be nice if one of its, I guess, associated types was actually the return type. Wouldn't that be cool? Because it could automatically be generated. Everything else about the FN trait for a particular signature function is presumably known. Everything about it is presumably known. The compiler could. Where f is fn args plus sized. Yeah, so here are the associated types. Except it has things like the allocator and other things. It has the function f. Yeah, pity, right? Be nice to actually be able to grab the return type. So it has to be artist. So I can't do anything about it here. I can't do anything about it in the myZipWith structure, I don't think. I don't think it's available. Rust generics work different from C++ templates. Rust has to know things ahead of time. And C++ templates get figured out when using them. That is a good point. That is a good point. It's a very interesting point. But, okay, that may be true, but let's take a look at, for example, I don't think I can do anything about it here. I agree with you that I can't do anything about it here because at best, there's a free variable, a free type variable. I'm arguing about a language I know very little about. This is ridiculous. I'm trying to think of where you could where that might actually be a plausible thing to be able to do. And you're right, I don't think there is, because I have to be able to state when I'm even setting up the constraint what C is, and I can't get that from anywhere else. Like, the act of actually stating the constraint at all requires me to have a placeholder for the return value. All right, you know what? I am kind of okay with that, given you can define associated type in a trait. Yes, but the associated type... that's true... And I'm willing to bet that in a function where I passed in, so let's take a look at this. For example, yes, please do. Doc Rust, let's go take a look at it. stdops add. Oh, type output, look at that. Yeah. Well, if you're, yeah, you can totally do an associated type inside a trait. I've seen that before. But this add operation, so that you're totally correct. But this, So the question is, that's actually a really good example. The link. Yes, so you could totally do that, and the question is, why is that not done for the function trait, the fn trait? Because I'm basically saying here, for example, f is required to be constrained to be a function that has this signature. And if I had a function which took this thing, C could be deduced from the actual value I passed in. Like here. Right? So what's happening here is that I don't need to specify C when I'm calling my zip with. If I call my zip with any function that fits the bill, it is being constrained by f, and f is constrained to be this. And then it can automatically deduce C for me. I don't actually have to specify it. But actually, this is how I extract the type. Because as part of the type deduction mechanism, by using an actual function f here at all, an actual value here, it can type deduce what C is, and then C gets passed off and inward. But it means that with the structure here, I have no way to deduce it from these parameters because I'm not actually providing values, I'm just providing types. I have to get that type from an actual variable. So, okay. Yeah. This is effectively, implicitly, that output associated type. This is how it gets pattern matched. At the type level. Heady stuff. However, this is an interesting point. So here's what I want to try to see if I can clean this up a little bit. Let's say, now I moved my b iterator down into the function here, but I'm going to try something here. I'm going to try doing this. If I put b back out here and take it out of this, right? I'm not saying it's a good idea, but if I did this, then I could say that my zippable has the... am I doing this right? I need a type alias. I need a type alias. Here ups fn. Type C is equal to, and it's actually going to be this guy here, because now I have the information in order to be able to build that. And then I can do, this isn't fabulous, but it's at least a little bit more condensed. Right, I can do that, I think. But I have to take out this where b iterator clause because it's no longer at that level. So let's try that, and then I think I have to clean up the rest of this as well. I don't know if this is going to work, just bear with me. This is more for my own crazy curiosity. But I also need to do that, and then it needs to be a part of my zippable A and B, because it now takes both of those. But I need to do it for A because that's the left-hand side, that's fine. I no longer need this here, and I no longer need this, and the where. Everything else flows, but again, if I'm implementing this, actually, I don't know if I can do this at the trait level. I don't know if I can define it at the trait level, but let's find out. Let's just, for giggles, let's find out. So I might not be able to do it at the trait level as a default. I saw mentioned something there. I might be able to do it in the impl. But satisfying the itch of demented type wizardry curiosity. Here we go. Cannot find the type C in this scope. Because why? Because you know what's really interesting is it did not object to me having C up at this level. So the question is, can I get access to the base, to the, if I'm implementing a trait, can I not get access to, I'm implementing it for A. Is there no way for me to get access to this C from in here? I mean, I could just do it again. That's the reason why I couldn't do that again. Bang. Nope, and like that. Cannot find type C. Oh, self : C. Because okay, hang on. Let me temporarily get rid of that again. What was the old error? You might have meant type self : C. Okay. Let's. Okay. Guess that's a thing. 106. Oh, it's at 106 it's complaining. Okay. Associated type defaults are unstable at 105. Okay. I need to think that out. But let's actually try getting the Rust compiler information. Yeah, I'm going way out on a type limb here. 0658. Using a stable or beta version of Rust C, you won't be able to use any unstable features. Using a nightly version, just add the corresponding feature to be able to use it. Okay. Oh, by unstable, it doesn't mean sort of unstable in the code. It means potentially unstable features. So it's basically saying, if you're using, okay, so associated type defaults are unstable. Why? I mean, it's basically based on the types that are being passed in. Just type C in trait definition to specify the C. So just type C : in trait definition and specify the type C equals in the implementation. So you're saying basically this. Okay, so, and then leaving that for the moment, if I then tried to do a build, it would tell me not all trait items implemented, missing C. In implementation for, oh, interesting. Yes, okay. So this is actually very interesting. So, okay, but you see, and that's the interesting part, right? Okay. Right, because I could do type C equals A item, B item. Sure. Okay. Because C is an associated type here, but we can't bind it to anything specific, but each and every individual implementation can. But that's interesting, because, I mean, that is something that makes sense to put in a trait default if it can be completely derived from the input types, because it will never ever not be it will never ever not be A : item, B : item. And I mean, I get that up here that's not actually defined as any specific type. I get that. And I get that this is being defined for a specific type. But it's interesting that you could, I mean, in theory, you could see, I suppose, I hope, that if it were up here, then when you go to do this and you're trying, it would have to import all of these kinds of types and then do the substitution based on the actual types of A and B, in principle. I mean, maybe there are compiler or, deep type system reasons why that's problematic. Because I totally see that a default for that case would make a lot of sense. But, okay. Now, let me think about this for a second. Why am I required to have this in here? Well, it's set unstable feature, so it's planned. Yeah, okay, no, that's totally fair. And actually, that's kind of cool that they're continuing to explore this stuff. I mean, that's what made Haskell great, because they're very big into their complicated type system stuff. And I like that they're doing that in Rust too. That's great. Makes me want to use it even more. But it makes sense to me that being able to do stuff at a global level when it's totally derivable from parameters is a totally sensible thing to do, provided it breaks nothing. You don't want to make things unstable. So if I do that without having C, it says it cannot find C in this scope. So among my options are to use self because it comes from A. So I can't refer to these type aliases except through either C or A, I guess. I mean, if I did this, I'm technically implementing this for A. Associated type C is not found for A because A is an iterator. A is an iterator, but it's not this implementation on this trait. And there it is. That's sort of the connection between A here and self. Again, it's another thing between A and self, because in the other case, I was trying to get at self's item. In this case, I'm trying to get at A's C, and that's just, okay, that totally makes sense. I can totally cope with that. I can totally cope with that. And I could do the as syntax or something else to get around that. So let's see if this actually runs, shall we? Because that'd be a thing. Anyway, I like this just a little bit more because I could call this ret or R for return type or something. But C is just as good. Why not R? I like R. I'm just being pedantic now on naming. Something sufficiently far along in the... Anyway. See, I like that. That's just a little bit of extra cleanup because of the specific case that I know here. Just so this doesn't get quite as bad. Now, the thing is... yeah. I don't think I can do... I think we're getting to the point where I can't do anything better than this. Because I need the type of the actual thing I'm going to use and not some external function, unless I can get F to... Like, if I put F in here, I'd have to basically say F is the type of whatever this is. Now, I wonder... if I could call a dummy function in order to capture this thing's type without doing any real work. in order to bind what f is. Like, actually, that conceivably could already have been written. Is there a type of function in Rust? Not to generate a dynamic type, but to capture the statically known type at that point. And I can't build structs. So, Rust. Type of. No, don't care about printing. The often useful type of. There we go, something like this. Type of self.0, whatever. I guess you can approximate this somewhat verbosely, but perhaps not too bad, with macros as a trait max, impl max for, etc., etc. Huh. Just it addressing the itch of curiosity. What if I did something like function foo, lowercase, on t, takes a t ref, I guess. I really don't care. Trying to do this as fakely as possible. T is t, and do nothing. It does not like that. Expected due to this expected type parameter t found reference. Brain is not functioning. I don't remember how to do this. Come on, basic functions. Get my brain in the game here. Come on. I'm just getting tired. Rust. Function. Functions. Rust function taking a parameter x colon. Well, start with that. Foo is never used. Rust function that only takes references. Can we even force that? You put the reference before the type. Yeah, before that makes sense. Before as declaring a part of the type. Just being dumb. Thank you. Infinitely. And use variable t. Okay. And I can probably do what? Can I use that as a placeholder for a variable as well? Yes, I can. I'm totally good with that. So if I do that, if I were to take, you know what, I'm not going to mangle this. Let's actually copy that up here so I don't accidentally lose it. Now I've taken all of this time to invent this. Invent. Vaguely learn. Right. So what I want to be able to do is I want to be able to say I want to be able to deduce the type of T. How do I even do that? This may not even be possible. Like, basically what I kind of want to do is I, again, want to return this to F. But in order to deduce F, we'll overload it or defaults. Actually, that's an interesting question. Rust default parameters. I doubt it. Default function arguments in Rust. No, Rust does not support it. And, you know, macros to do that kind of crazy crap. I might be able to expose this maybe with a macro. I'm trying to do this without using macros. I need to be able to, in order to be able to get F out of this, I still kind of need a type of operation. I need to be able to elevate information about a value up to the type level. Because at this point in the impl, I know all the actual concrete types. Well, no, I don't. I mean, I actually kind of don't. Because, again, this isn't C++. It doesn't evaluate this stuff after the substitution. It has to be known with the things that I have available here. The only place I know this is when I need to know the type of this, but I need to know the type of this kind of thing after I know the types of X and Y. Sorry, no, after I know the type of IY and self. Yeah, this is not going to take me down anywhere sensible. Basically, I would need, yeah, okay. In order for this to work, I would have to be able to take a value and ask for its type, but do so sort of this doesn't even have a type until after it has been deduced with the other properties of self my zip width. Like, I'm not specifying a type for X or Y here. So this, as an expression, doesn't even have concrete types. Everything's a generic. Okay, then. I think that's about the best I can do. All right. So let's say that yeah. I can experiment with that down the road. That's as much as I'm willing to do on stream anyway. Like, as I understand the type system more and more, and where I can use type aliases and where I can use the where clauses and so on, I will probably get more sophisticated about that. But that's not the point. I did actually come here with an intent to write the one thing that I have not written yet, which is I have to make another copy of all of this and all of this, because it's time to do the actual thing that I was after doing. How long have I been going? 3 hours and 34 minutes. Okay. It has actually gotten a little bit into the evening. It's already 6. So how do I want to do this? Screw it. Let's just have at it. We're having at it. This is crazy. So this is going to be my my merge zip width. So I'm going to relabel. I'm just going to do a search and replace on this. Merge zip. Hang on. No, actually that'll do. That'll be fine. Zip width, merge zip width. So this is going to basically come full circle to the original reason I got into this, and I can fiddle with this a little bit later. So we're going to replace, and we're going to hang on, replace. Now we're too far. My merge zip withable. Oh, this is just so nonsense. So we got to be a little bit more elaborate here. No, actually, I'm not going to be able to complete this evening. I'm going to have to go into a step 3, I think, because this is going to require several more functions. I saw that you had Advent of Code open, so I have you with my impl of 2020 day 3. Spoiler, it uses iterators. Great. I have not done... I may have done up to number 3, I don't recall, but not in Rust. This is literally the first thing that I've done as a major step in Rust, and it doesn't even properly implement the Advent of Code thing because it doesn't do the final stage of doing the multiplication, because that wasn't the interesting bit to me. Okay. Challenge accepted. What I'm going to do is I'm going to copy that. Hang on, I'm just going to pull that open in my other browser here. Twitch. Let's do the thing. Let's go to my own account. I'm going to pull up that link, and I'm going to look at it after I have attempted to solve it myself. Because actually writing problem solutions where, like, I have concrete types and I don't have to worry about all this generic stuff, it's probably going to be easier than the crap that I'm doing right now on screen for everyone. Alright, so quickly pop over to my channel. Pop over actually to the video producer because it's easier to see the chat room. Don't care about watching the stream. Please don't load that up, because what I'm going to do is I'm going to pull up but hide. I'm actually going to copy the address over into Programmer's Notepad. Sweet. So that I don't forget it, but I don't want to look at the solution until after I attempt to implement it myself. Actually, the Advent of Code would be a great thing to cut my teeth on, because it would require way less jiggery-pokery than I'm doing here. So I should actually go and do that. Okay, so my intent is to eventually write my merge zip withable. Also gives you a chance to VS Code and to VS Code in the Rust Analyzer extension. I have, what do I have here? I have Visual Studio 2019. Hopefully it has an extension as well, because I think VS Code is the other Microsoft Visual Studio-like application that packages it up a bit differently. I can't remember. I don't think I have VS Code, but I will look for a Rust Analyzer extension, and I will maybe start using that instead of just doing stuff straight in text like this. Good call. Yeah, so my intention on the next stream, so that I can take a break from this and think about how I want to tackle this, is it'll require a couple of extra functions. It'll probably take actually less time than what I've already done, because I've already got the pieces for it. But my solution will require 2 extra functions to deal with the tails of the list. Some slightly different functions, because my functions have to return behavior on how to step through the individual lists, which I showed in the other 3 language versions of the function. I want to try to implement it the same way, even if it's not the best way. That's not my point. That's going to take me a little longer than I want to spend sitting here talking to everybody, because I'm already at the 3-hour, 40-minute mark. But it's going to look very, very similar to this, and eventually I'm going to be able to do that, the final steps, where I default both zip and zip width to using this, and then also do the merge part of merge sort, and the sum to n part of the Advent puzzle using it. So I think that's where we're going to call it. This has been so much fun. So, given that this is a Sunday, that means that I probably don't want to leave this all the way until next weekend, but because I actually have an actual job I have to do, maybe I will try to get to this about another little bout of this, maybe 7 p.m. PST on Monday or Tuesday. You'll have to look for me then. That'd be about 10 p.m. EST. I don't know what it is overseas. And I guess we're technically daylight standard time, or daylight time, not standard time, but whatever. God, I hate time zones. If this does get delayed till the next weekend, then you'll find me around this time, sort of in the early afternoon. But I kind of want to keep pressing on this, because the harder I press on it, the more I'm going to learn faster. And I want to get this last chunk done. Yeah. So, every one of you who stopped by to say hi, I am not a Rust veteran, I'm a Rust noob, but I've enjoyed doing this with all of you, partly because people are providing some great insights to me as I'm coding. Again, a major shout out to SilenZ, or Silence. I don't even know how to pronounce that, SilenZ, because I'm going to go with the underscore you have in there. And it has been absolutely fantastic. I'm going to keep doing this. I want to learn Rust. I want to get better at this. I want to figure out how its type system works, and I want to figure out all the traits that are in the system. It's been fabulous. I will hopefully see some of you in my next stream. Thank you so much.